We're here, so perhaps you didn't notice it. I'm pretty sure you didn't. I'm French. So sorry for my accent. I'm trying to do my best. I'm really excited to be there, but I will try to speak slowly. Feel free to ping me if you don't understand some of the stuff I say. I will translate that for you in English. So if you want to reach me, just ping me on Twitter. And today I would like to talk about something totally not related to Microsoft. But I will do some disruptive stuff. I will use Windows 10, and I will use Edge. So it's barely, I'm pretty sure it's new for all of you. So that's a good way for you to discover this wonderful new browser, which is not IE. And that's clearly easier for me now, because for previous conference, hey, hello everyone, I'm working for IE, and then everyone will just not listen to me. So this time it's not IE. So let's go back to our subject. What WebGL is? WebGL is a JavaScript API that you can use barely on all new browsers. You can see here the new Edge icon, and you can see how different is it from IE icon, which is cool. Back to the WebGL. So WebGL is based on OpenGL ES 2.0, and it's standardized not by the W3C or the WhatWG, but by the Kronos group. Cool. So WebGL could be used directly. It's an API that you can call from your JavaScript code, but it's a really low level API, meaning you're barely on the metal, so you can directly discuss with the GPU, but you will know that the GPU is a really tough guy. So you have to deal with everything. And most of the time, when you deal with WebGL, it's like math, and a little bit of math. And most of the time, using WebGL, when I see people using WebGL directly, they feel like these cats. It's like, no, never, ever, I will use WebGL. So that's why I decided to write something for you guys. I did that on my spare time, but apparently it was successful, and we have now a lot of big projects that use it. Ubisoft in France is using it for Assassin's Creed Pirates on the web, for instance. We use it at Microsoft also for some Xbox stuff. It's an open source project that you can find on GitHub. It's under Apache 2. So it's not the regular Microsoft that you may know. It's something totally free. There is no trick. You can contribute if you want. You don't have to pay anything. And I would like to show you today how to use Babylon.js if you want to do 3D on the web, which is just awesome, with no plugin at all, and with no headache at all as well. So you just can go to www.babylonjs.com to get it. Or we have a CDN for the very latest version, which is 2.1. This version is really fresh. We published it like 3 weeks ago. So I'm here to present you some of the good news we added on top of it. If you want to use it, it's just one single library, Babylon.js. And if you want to use it, the main friend you will have will be the engine. The engine is the guy that will talk with the tough guy. The engine is the smart guy, that your friend. And this smart guy knows how to deal with maths, with GPU, and with all the weird stuff that happens between the CPU and the GPU. And you, as the user of the engine, you just have to ask, hey, please draw me a 3D object there. Thank you. And he will translate that into assembly code that just stinks. So, from the point of view of a JavaScript developer, you have to deal with a high-level scene graph API, meaning that you create a scene, and inside this scene, you will just add objects. First of all, you will add a camera, which is you. Where are you inside this scene? We have different kinds of camera. I'll get back to that quickly. We then add lights, and we then create 3D objects. Pretty simple. We have out-of-the-box basic objects like sphere, box, torus, donuts, etc., etc. And then, because we are dealing with 3D, because we need to render as fast as possible, we have a render loop. The render loop is a common concept when you deal with 3D. You have to pump a lot of pictures every second to be sure that the user feels the smoothness and the animation. To do that, we just have one line of code to code, like engine.run_render_loop, and just call scene.render. That's pretty much it. So let's go to some code. I have here, I'm not using Sublime Text. I'm using Visual Studio Code. Boom, advertising. It's subtle, right? So how to do that? It's pretty simple. It's just a simple page where I'm just referencing Babylon.js on the main server, and I just have a render canvas here. I want to use this render canvas full screen, and then get this render canvas here, initialize my engine. The Boolean here define I want anti-aliasing. Okay, I want to remove, I want to have smooth pictures. And then I have a create scene function here where I create my scene, as I mentioned before. I'm creating a camera. This one is a arc rotate camera, meaning it's a camera that is centered on an object and I can rotate around, okay, like in a sphere. Then I ask the camera to control all the inputs, meaning touch, mouse, keyboard, gamepad, you name it, will be handled for you by the camera, so you just have to interact with your scene, and everything else is handled for you by the camera. We had a light, a sphere, which is a box, a wonderful demonstration. I just found it. So it's a box and not a sphere. It's a box named sphere. That's okay. I'm open. We are in the Washington State. Everything is permitted here, so that's okay. It's a transgenre. Formerly a box. Then I create a material. The material is a way to define how you will render your object. Okay, by nature, an object has no way to know the color of every vertices and every pixel used by it. So the standard material here, we say, okay, oops, you will just have a color which is red, no blue, green, no green, blue, so red and blue meaning I think it's purple. I attach this material to the sphere, and that's it. So it's more a declarative way of using it. I want something. Then you create the scene and just run your render loop. The result, boom, it's not Chrome. It's Edge. So you have a box here, purple. It's cool. You can rotate around. Because we are supporting touch as well, I can do that with my finger here. I can zoom if I want. Pretty simple. And Babylon.js is handling for you everything related to shaders and whatever. Going back to shaders, we can also define more interesting stuff, like, so same story, I have a render canvas here, I create my scene the same way, but this time I create a box which is a box, not the evolution, and also a real sphere, which is a sphere, a plane, a cylinder, a torus knot, which is really cool. I don't know if you know what's a torus knot. I will show you. That's just huge. Some lines. And then I can play with position. We are dealing with 3D space. So we have X, Y, Z. Position, so I can move them all around. And then my scene is ready to go. So the result is, by not just creating a box, but also a lot of other stuff, now I have, as you can see here, my sphere, my box, my plane, my donut, my cylinder, and the torus knot, which is this stuff. It's like a sausage which has some issues. And interestingly, now I just ask, okay, scene, please render, but before rendering, just change the rotation of my sausage here, and you can see that, yeah, it's rotating. Whoa. It's smooth and beautiful, I know. We can spend hours just watching this demo, I'm pretty sure. Then, next one, going further, same story, I have my scene, I have my camera, and now I create 6 spheres, and I will move this sphere on a single line here, so from the left to the right, a plane, and now I will give them different materials, okay? So for instance, here, the first material will say, okay, just render as a wireframe, okay? Don't fill it, just render the lines. The second one will say, okay, here is your color, you will be red, but you will be also almost transparent, okay? The third one say, okay, just don't use a plain color, please use a texture, which is this one. Then you can also say, you can mix stuff. You can say, okay, I have a texture, but I would like to move the texture on the object. Okay? And then I can have a texture which is transparent, Or I can have a texture which is transparent, and I don't want to remove backface culling. I will show you what is that. And finally, I can have a texture which don't have backface culling, and where I play with the scale to multiply the texture on top of the object. So let's see the result. It will be easier to understand for you guys. Oops. And now we have 6 spheres. The very first one here is just wireframe. The second one is red, but almost transparent. The third one is just a texture. The fourth one is a texture, but different position of the texture on top of the object. The fifth one is interesting. We are using a texture, but where there is black, instead of writing black, we remove the pixels. So it looks like we can see through it, okay? But there is what we call backface culling, removing the face which are backwards from you, so we don't need to see them. For instance, for these two one, we don't need to render the face which are in the other side of the object. And that's why for the last one, we ask, please don't remove backface. That's not easy to see here, but you can see we can see inside the object, okay? And it's just like every time, a few lines of code to do that. Finally, we can also say, I have my canvas, blah, blah, blah. And this time, I will play with something totally different. But because creating a 3D sphere is not just about creating objects, it's also creating animations, and in this case, particles. You can create, it's out of the box, particle system. A particle system is based on small dots, and you can control how they behave. For instance, here I will say, okay, my particle will use this specific texture. They will be emitted from the fountain. The fountain is just there. It's a simple box on my scene. And then they will have a color between color 1 and color 2. They will have this color when they will die. They will have a size between that and that, different lifetime, blah, blah, blah. So you can define a lot of stuff, gravity, direction. And the result is that you can play with particles dynamically inside your browser. Particles are really interesting for instance, explosions, fire, smoke, etc. So here, I'm just rotating my emitter, which is the fountain here, and you can see that the engine will just generate for you particles with colors between first and second, and blah, blah, blah. All right? So going back to my slides. Now you're convinced. You want to live with Babylon.js. You want to experiment it. So for that, we shipped 2 different tools that you can find online, still free. It's working for Microsoft, you still have to do that a lot of time. The very first one is the playground. The playground is a place where you can live code and see the result. For instance, here I have this scene, which is just defined here. Let's say the intensity of my light is not what I want. I want 1 instead of 0.7. And you can just run again. Or you don't want a sphere here. You want to move your sphere. We added for you IntelliSense. So inside the browser, you can have all the help. I think as a developer, it's easier for me to learn something by practicing and experimenting than reading the documentation. Reading the documentation meaning, okay, going to the website where there is the documentation and closing the browser, most of the time. Here, if you want to play with it, because there is this help, you can learn, for instance, that position here is an object where you can, for instance, play with hex and say, let's move it 4 on the right. Boom. Wow. Yeah, I know. So we created for you guys a lot of, let me increase the font a little bit. Yeah. We created for you guys a lot of different, let's say, tutorials where you can learn how to play with camera, light, animation, sprite, collision, intersection, picking, particle, blah, 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 blah. Shadows, for instance, live and real-time shadows where we have these 2 lights here that generate wonderful live shadow. To do that, the code is just here. When you're happy with what you are doing, you can just click on Get Zip. It will generate for you a simple page with everything already set up, potentially texture, so you can just copy-paste that on your website. And if you want to share, that's the main goal of the playground, actually. If you want to share what you're doing, for instance, I will do something so fancy, for instance, like changing the intensity to 1, boom, and then I can run that. I'm so proud of that. I can just click on Save. It will generate for you, like in JS Fiddle, a unique URL And you can share that with your friend and say, hey, look, I'm so wonderful designer. I create 3D stuff that rotate with the donuts. The other one is the CYOS. This one is a little bit more complicated. If you want to go further than just using the standard material, you can. You can even deal with the GPU. I warn you, it's a tough guy, but if you talk the right way with him, it could be interesting. So here you will learn how to create shaders. So we have here, same story actually. It's a space where you define both shaders. I don't want to go deep inside this specific stuff. If you're interested in shaders, just ping me. It's a way for you to understand how shaders are working. This code here will be compiled to a assembly code that will directly be generated and executed on the GPU. So I can control how every pixel in the screen is generated. So you have the sausage here, and you can, for instance, look, it will be magic. I want to do something like .rrr, meaning give me some black and white. No. Oh yeah, man. It's like RRRA, obviously. You fixed it by yourself, yes. And now it's black and white. Wow, that's the power of shaders. You have different kind of shaders here, like for instance the environmental, oh yeah, this one, where you can see reflection. That's cool. You can just read the shaders here if you want to understand how shaders can work. All right. But now it's just about sausage and box. I'm pretty happy to deal with sausage, but most of the time you need to go further if you want to create a 3D application. So that's why we also shipped tools for you to create content. It won't be for you most of the time. It will be for 3D designers that can help you. So Blender 3D is supported. You can just create your scene under Blender 3D, click a button, and generate a .Babylon 5. You can also work with 3ds Max. And now this is a pretty new stuff that we added for the very latest version. You can even deal with, let's go here, Unity 5. So this is Unity 5. I just bought this wonderful spaceship on the Unity store. That's interesting if you're a developer and you don't have 3D designer with you. You can buy content on the Unity store. There are a lot of them. This one is free, so buying for free is interesting. And you can just use the Babylon.js exporter here to just generate for you in like a couple of seconds. It will generate for you, hopefully, sounds like yes. A .Babylon 5 with all the assets required. And I have to wait a little bit. Yes. I'm pretty sure it's working. It's just like, you know, waiting, blah. Okay, oh, boom. I love this kind. This is how we work. It's like 0 to 100. No need, it's just integer. No need for double or whatever. So if you're going to Babylon, and look, it's not Edge because I'm really open-minded. I'm using now Chrome if I want. I'm doing what I want. If you go to Chrome, you can, to babylonjs.com, you will see the sandbox. The sandbox is a tool for your designer, or even for you, to directly test your assets without having to create a page with all the stuff. Even if it's not complicated, most of the time, we are developers. We don't want to write a lot of code. So this is the stuff exported from me from Unity, and I just have to open them inside the sandbox, wait like not too long, okay, and boom, we have inside my browser the spaceship that I can use now to create the next wonderful game that you want to create. It's just directly. So you don't have to deal with create box, via whatever. Everything here will be done for you from Unity 5. But even if Unity 5 is free and work well with PC and Mac, yeah, you know the stuff with the Apple, It was not enough. We met with developers that say, hey, no, I'm running under Linux. Man, really? So let's introduce a new feature that we also shipped, which is the support of Clara.io. If you don't know Clara.io, please let me introduce you with Clara.io, which is here. Clara.io is not something related to me at all. It's a tool that you can find online. There are a bunch of guys from Canada, so not far from here. They created this incredible 3D editor purely on the web. These guys are just mad. Everything is supported. Like you can create this TIE fighter in a couple of minutes if you're good. And the interesting thing here is that you can click on File, and you can click on File again if you want. You can do that twice. That's interesting. And you can click here, and you will have support for Babylon.js directly inside Clara.io. So even if you're running on Linux, that's not a problem. You can still create or ask your designer to create really cool assets like this one. I'm just waiting for the stuff to be prepared. Going to the sandbox, this time using Edge, so it's really open. It works on at least 2 browsers. And once it's done, yeah, I think it's done. Oh yeah, it's done. So I can download it, boom. I already did it, unless the Wi-Fi is really fast. It was. Thank you. Let me put that on the desktop. Yes, replace this one. And just opening the sandbox. And I want to use a Star Wars TIE fighter. And this time, boom. So there is a sphere. Yeah, I put a sphere because I thought that it was too beautiful. So I decided to add a sphere. And you can still use that if you want. You may need to ask Disney if they allow you to do that, but you can. So, go back to my slides. All these tools will generate for you .babylon files. We have now 3 different Babylon file formats. The very first one is a JSON format. So you can read it. And I will show you a scene, which is the virtual museum. The virtual museum is 22 megabytes. When you use the JSON file, is a little bit too much, even with the internet we have today. You can then move to something called the incremental.babylon.js. In this file, it's not just one single file, but just a skeleton with all objects in your scene inside separate files. So it allows you to download the scene while moving. Let's say you want to, for instance, generate New York. You won't download New York in just one call. You will just generate the place where you are. And while moving, while walking, you will load different objects, different parts of your scene. This could be done with the incremental.babylon. It's like streaming 3D inside your browser. And we also support binary, meaning that the main Babylon file, the skeleton, will still remain in JSON, but all 3D assets, all the geometries will be packed inside binary format. So the final scene can move, depending on what you want to do, from 22 megabytes to 9 megabytes. And with JZip, it's just 3 megabytes. Then, we also have different cameras, which is interesting. So far, I show you the arc rotate camera. We have touch support camera. We have device orientation cameras. We have virtual joysticks camera. So you just have to touch on left and right of your PC. We support anaglyph as well. VR. So working, that's a shame, but only on Chrome and Firefox, you will have WebVR. So it's a way for you to support cardboards or Oculus Rift or whatever. And we also support gamepad. So if you want to support gamepad, just create, instead of creating new arc rotate camera, you will create new gamepad camera. That's it. You don't have to do anything else. So I just saw, like you, the talk from Dave just before, and wow, it was about web audio. So I decided to tweak my slide a little bit, because with 2.1, we also added support for web audio. So let me move to... I will be totally honest with you. We have a bug on Edge with web audio. So I have no choice. I have to use Chrome. But it will be fixed by end of this month, obviously. So this scene was made to really and phase on web audio support inside a 3D environment. Because the sound is really important when you want to deal with 3D, because it helps support and create a mood, good immersive experience. I'm just waiting for the network to be OK with us. Oh, sound here. 2, like the latest one. 1. 1. It's like 0.5 actually, but we don't have it. OK, so this scene was done for me by a designer using 3ds Max. As you can see, we can wander around. We have some stuff really cool, like this God of Raid stuff that you can see, the moon. And while moving, you can see that the 3D sound will be, I'm not sure it's really obvious in the room, but we have 3D sound positioning. And I have something for you guys. We decided to kill people at Microsoft. The first one we killed was Clippy. So we killed Clippy, and you asked for it, you prayed for it, you cried for it. We also killed IE6. And now we are calling Edge to help you. Another web audio demo I would like to do, because the talk from Dave was so cool. Let me go back to the doc. So doc.babylonjs.com, we have support for a lot of stuff from Babylon.js with web audio. And we have this cool demonstration. Interesting. There is a link here. OK. So it's exactly what you mentioned before, Dave. It's an analyzer, but this analyzer now is linked to a 3D object. It's a frequency analyzer. So exactly the same stuff. You can try that inside Babylon.js if you want. It's a little bit of code here. Then, and because I'm running late, I just want to skip a lot of stuff here. We have tons of features for you guys. The best way to discover it is either pinging me on Twitter if you want, or just try it. It's free. We are looking for contributors. We already have a bunch of them. But if you're happy to deal with 3D, please come. Useful link. And that's it. Thank you very much.